All right, good evening. So, for the purpose of the recording again, let me start. So, good evening, everyone. Thank you for joining in. So, this week we are starting our skills training and hands-on sessions. Today we'll be focusing on Python, the fundamentals of Python. Tomorrow it will be on data manipulation, and another day on data visualization. So you get to understand the meaning of all this in the process, but all this is meant to build you up for the days during the week where we'll be working on a machine learning model. So you guys will build along with the instructor. So we have our speaker here, Divine, for today's session. So Divine is a computer science student at Dell's University of Technology, and he's a software engineer with a focus on backend. He has won several awards and was the winner for Hot Prize Nigeria 2025. So Divine will be taking you on this journey today. So get your devices ready and over to you, Divine.
Okay, good evening, everyone. Am I audible, please?
Yeah, we
Okay,
can.
I see the thumbs up. Thank you. So thank you for the introduction, Samuel. Just to reintroduce myself, my name is Divine Afam Ifediogo. I am a software engineer focusing on backend development, primarily with Python. So I'm glad to be here. So to begin, I will be sharing my screen. 1 second. Yes, there we go. So I believe my screen is visible now. Okay. So to begin, let's go over a brief introduction of what Python is. So Python is a high-level general-purpose programming language developed by Guido van Rossum, but managed by the Python Software Foundation in 1991. So that's about 35 years ago. So one of the Python is used in a lot of areas within the software industry, from data science to machine learning to backend development to even embedded systems in some cases. And one of the reasons for its mass adoption is its simple syntax. So what that means is Python is very easy to understand because it is designed after or fashioned in similar. Okay, Python looks very similar to regular English that you and I use every day. So yes, I see the collab link. I have my own collab notebook, by the way. I will drop the link to that if you want to follow along with me. But you can also create your own notebook using the link that Samuel has posted. So there is my link. Yeah. So also, for our benefit, I will also drop a link to a cheat sheet for Python that you can peruse at your own time. It contains all of the concepts that we'll be going over in this session. Yes. So to begin, let's start with the most fundamental concept in programming languages, and that is variables. Now, we create programs mainly to do one thing. We create programs to take in input, perform some form of processing on that input, and give out some form of output. And to do so, we have to store that data somehow in the course of our program. And that's what a variable is basically. It's a label for a value within your code. So in Python, to define a variable, let's say if you wanted to store my name as a variable, it would do so like this. So we could have name equals define, just like that. So what this does is it creates a string, and a string is just a set of arbitrary characters, and it assigns that string as the value for the name variable. Yeah. So if we do something else, like print name in here, you can see we get divine printed out. Now this print it's called a function, and it's a built-in function to Python. So we'll get to functions in a bit, but just know that print here outputs a value. Now, because we are in Colab, Colab, by the way, it's an environment by Google, and it allows you to work with Python code within your browser without having to set up an environment. So if we have the time at the end of the session, I would take us through how to set up an environment locally on our systems without the need for Colab or an internet connection. So that is a variable. Now, this data here that represents my name, Divine, if you recall, I said it's a string. Now, a string is simply a data type that is used to, like I said, represent a set of characters. But let's say we wanted to store my age, for instance, right? We could have another variable. Let's say age is equal to 50, right? Now, if you notice, we don't have the double quotes around them. And when we do that, that tells Python that this is supposed to be a number. And in Python, numerical values like these, whole number values, are known as ints or integers. So what we are doing here is we are defining a variable called age, and we are setting, you can see its highlights here. We are setting the value of the variable age to be an integer with the value of 50. Yeah. So those are the first two data types and the most common ones that you'll come across. So if you had the cheat sheet open, we have come across print, we have come across hello, okay. We have come across variables. Okay, now the next data type I'd like us to see is lists. So things like strings and integers are what we could call primitive data types, right? And these primitive data types are the building blocks for other data types as well. So in addition to that, we have compound data types. So an example of a compound data type is a list. So as the name implies, a list is a collection of elements in contiguous memory order. And to define a list within Python, let's say we wanted to define a grocery list or a shopping list, for instance, we could do that like this. So shopping list equals, by the way, equals, the equal sign is used to assign values to variables. Yeah. So to create a list, we use the square brackets like this. So inside of our shopping list, we can have the names of things we want to buy. Like, let's say apples. We can have a banana. We can have a coconut for some reason. Yeah. And if we print out our shopping list, you can see the values within that list like that. So lists allow us to, or rather lists act like a container for values within our code. So we don't have to create individual variables for each of these values. We can just store them within a list and work with all of them together at the same time. Now, one of the cool things about these data types is each data type has specific operations that you can carry out on each of them. So for example, strings have their own things that you can do with them. These operations are called methods, by the way. So an example of a string method would be, let's say, name dot upper. When we run that, you can see it outputs the value of the name variable, but in uppercase. So it capitalizes all the letters of my name. We can also do something else like name dot lower. And you can see it makes it lowercase there. So just using the autocomplete here, you can see there's actually a bunch more of those string methods that we can use. So each one of these methods can transform the data that you have in that string, operations on each one of them. So of course, one of the things we can do with the integer data type is we can perform arithmetic operations on them. So we can do something like age divided by 2. Yes, in Python, division is represented with a / in between the operands. So if we run this, you can see we have 25.0. Now, this 25.0 is not exactly an integer. Instead, in Python, it is known by a separate data type called a float. It stands for floating point digit. Now, the reason why it's called a floating point digit has to do with how computers store decimal numbers. But for now, you don't need to delve into that. Just know that they are called floats. Now, to show another example of a float, for instance, let's say pi. You can say pi is equal to 3.14. So to define a float in Python, you just type out the number with a decimal point, and Python immediately knows that it is supposed to be a floating point number, just like that. So we can also do arithmetic operations on these floats. For instance, let's say we wanted to calculate the area of a circle, which is pi r squared. So let's say the radius of our circle is equal to 5 units. Of course, to calculate the area, it would be equal to pi. So we reference this variable here with the value of 3.14 times our radius squared. Now, Python has an operator for exponents. That's raising to the power of. So to do that, this is how we do it, 2 asterisks. Also, a single asterisk represents multiplication, so double asterisk represents exponentiation. So the area is equal to pi times the radius squared. And as you can see, we can use parentheses to separate parts of our equation. So it's going to follow order of operations from, again, basic arithmetic. So if we run that and print out the area like this, you can see 78.5 is our answer. So that's a brief introduction to the most basic data types that you come across within Python. Now, Going back to lists, right? We can do a bunch more stuff with lists. If you recall, I said lists allow us to work with a lot of data without having to assign each bit of that data to a separate variable. So let's say with this shopping list here, we actually wanted to go through each one of the items, right? We could do that using a programming concept known as a loop. Now, what a loop does is it simply executes a single instruction, or rather a block of instructions. It executes that repeatedly for as many times as you specify. So that is that can be applied to our list here to call out each item inside of the shopping list. So as you can see here, we've already defined the shopping list to have an apple, a banana, and a coconut. So to go through that, we would use a for loop, and the syntax goes for, let's call the intermediary variable fruit. So for each fruit within our shopping list, like that, we are going to print out the name of that fruit, like that. So if you notice, Python uses what's called indentation, that is, spaces from the main margin. And it uses this indentation to denote a block of code, right? So everything on the same indentation level, let's say I printed my name again, and I printed my age again. You can see all three of these statements have two spaces behind them. So they have the same level of indentation. And this means that these three statements are within the same block and they are under this for loop. That is what it means. So it means that everything under the for loop with the same indentation is going to run for every iteration of this for loop. So remember I said a loop runs things repeatedly, right? So every time it runs, it is going to go through each one of these statements over and over again. Now, of course, if I were to come down here and type print age again, this statement here would not run as part of this loop because you can see it is back on a different level of indentation. Yes. So let's clear this out and run this. So you can see it goes through each item. So each fruit in the shopping list, it gets the value for those and it prints them out like that. So we end up with apple, banana, and coconut. Yeah. So another thing we can do with lists is we can add things to a list. So let's say you forgot to add something to the list at the beginning where you first wrote out your list. If you wanted to add something after you had created that list, it's very easy to do. We can simply do shopping list dot append, and then we can add another fruit. Since we're going with ABC, what fruit starts with D? Let's go with durian. Okay. And if we run that and then print out our shopping list again, you can see, oh, yes, durian appears twice because we ran this initially before running it again. Yeah. So you can see we now have two instances of durian added to the end of our list. So that is what the append method does. And this append method is similar to the upper and lower methods of strings. So the same way these guys are unique to only strings, So also append is unique to lists. So that's what append does. It allows you to add things to the end of a list. But now you can see we have two instances of the word durian in here. So how do we remove one of them? To do that, we can run, oh, if I can just spell that correctly, we can run shopping list dot pop. And just for good measure, let's define another variable called last fruit. And if we run this and print out last fruit again, you can see last fruit now gives us the value durian. Now, the reason why this happened is this pop method here actually gets the last value inside of the list and removes it from the list. It then assigns it to whatever variable you have to assign it to. So as a result, last fruit ended up with the value durian. Now, if we print out our shopping list again, you can see the last durian has been removed from the list. Yeah, so that is one way we can add and remove things from a list. Now, you might notice we actually did not use the print function to get the value from this guy and this guy. And that is a feature of Google Colab, where if you simply type out a variable, it's going to give back the value of that variable without having to use the print statement. But if you have multiple statements within that block, then it's best to use the print function to explicitly tell it that you want to see that value printed out. Yeah. So moving on to the next concept, let's say we had a special list that we did not want anyone to be able to change. The ability to change the values of a data type in programming in general is known as mutability. So when you hear that something is mutable, and by the way, mutable is spelled M-U-T-A-B-L-E, when you hear that, it means that the value of that thing can be changed after you have defined what it is. And by default, in Python, most things are mutable. So variables by themselves are mutable. So what I mean by that is I could come down here. Remember, I had defined name to equal divine previously. So I can come down here and still redefine name to equal something else, like let's say George, right? And if I run print name again, you can see the value has changed. So this variable is mutable. Similarly, the list itself, the shopping list itself, is mutable because we can add and remove things from it. But let's say we wanted a list that was not mutable, like we did not want anyone to tamper with the contents of that list. There is a different data type that can help us with that, and that is called a tuple. Some people pronounce it tuple, can pronounce it however. What matters is whether your code runs. So let's define, okay, let's define a few elements, for instance. Of course, chemical elements can't just be like, you can't wake up one morning and define a new chemical element unless you are in the field of chemistry. But for this example, let's assume that our list of elements is not supposed to be changed. So we can have, let's call it elements like this, elements equals. Now to define a tuple, we use parentheses, right? And then we simply type in each value within the tuple. So examples of elements, we have hydrogen, we have helium, we have lithium, we have beryllium. Now, my apologies, I can't go any further. I don't really like chemistry, but those are our elements right there. Now, if we tried to, or if we wanted to add something to this set of elements, if you notice, we only have two methods on this tuple. So there isn't an append method that we can use to try and add stuff to the tuple of elements. There's no such thing. So the only way to change what this variable has is to redefine the entire variable. That's the only way that could happen. So those are tuples. They allow you to define a special list, so to speak, whose elements cannot be altered without, of course, redefining the entire variable. Now, of course, append and pop are not the only ways of adding and removing things from lists. In fact, there is a special shorthand for adding things to lists. So again, going back to our shopping list, let's say we wanted to add something to it. Let's say, okay, we have A, B, C, and D now. Let's go with something else with the letter E. Yeah, let's choose eggplant. So to add an eggplant, we can simply do this, a plus sign and equals sign. And we just type in the elements that we want to add. So eggplant, like that. And now, if we output the value of shopping list again, you can see, oh wow, that's my mistake. That's my mistake. What this actually did is this has shown that there is a similarity in how Python treats strings and lists. So remember I said a string is just an array of different characters, right? And a list is also an array of separate items. Now, internally, Python can treat strings and lists very similarly. So when we did this, this is actually supposed to extend the list, right? So it's supposed to extend the list with whatever we supply to it. So this should have been like that. So if we run this now, yeah, you can see it has added it properly here. Now we have a bunch of elements inside of our list, and we also have the results of that mistake that I made shortly. To remove all of these elements here, of course, these elements aren't at the end of the list anymore. So how do we remove them? To do so, we have to access different elements within the list, right? And a way we can access these things is using what is called indexing. So when it comes to lists, right? Each element within a list is identified by its position within that list, called an index. And indexes start at 0 in Python and most other self-respecting programming languages out there. So the index for this element here, Apple, is going to be 0. The index for this is 1. The index for this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if we wanted to get the item at index 12, we could simply do shopping list and then we use square brackets right beside the variable name, and then we type in the index 12. When we run that, you can see we get eggplant, which remember was at index 12. Similarly, if we want to get the element at index 4, which is this letter E, we can do 4 in there, and you can see we get the letter E. And if we want the element at index 11, which should be this letter T, and we run that, you see we have the letter T. Now, to remove all of these items here, we can do something called, we can reassign the value of shopping list and omit those items, right? So to do that, we have to use what is called a range. Now, a range is kind of like a slice of a list from a starting index to an end index, right? So to do that, we have our shopping list here. We use the square brackets to define the range again. So we start with element 0, and we want to pick out every element up to index 4. So from 0 to index 4. Now, when you define these ranges, they do not include the element at the end index. So what that means is this range of 0 to 4 will include only 0, 1, 2, and 3. It's not going to include 4. So 0 to 4, but not including the end index, or the element at the end index rather. So we also want to add shopping list, and that was 11, if I recall correctly. And we put that in a list as well, because now we are accessing an individual element. So this alone is going to return this value here. So we put it into a list by itself, so that when we get the slice of that list that contains only these elements, we can simply combine those lists together, and we would end up with our corrected shopping list, like that. Yeah, and let's time that. That should have been 12. Oh, index out of range. Okay, let's just use this shorthand here. So, okay, yeah. So this -1 here actually accesses the last element within that list. So it's like counting backwards from the end of the list. So going from 0, if this is at index 0, then the element at index -1 should be this down here. So if we run that again and run this again, well, okay, we ended up with, oh, right. So I made a mistake myself, and we ended up with 2 instances of the same list inside of itself. Okay. So moving on to a different type, or a different data type. Okay, we've touched on strings, integers, floats, lists, and tuples. So let's actually move on to control structures instead. Yeah, so a control structure, as the name implies, is something that we use within our code to determine the control flow of execution. So what that means is, depending on the type of inputs that you get, you might want to perform a different operation based on what you have. So to do that, you can use something called an if statement in Python. Now, an if statement allows you to check whether a specific condition is true or false. And if it is true, everything under that if statement will be executed. Otherwise, it would not be executed. So to show an example of that, let's say we were, we wanted to restrict who has access to vote, for instance. So to vote, you have to be 18 years of age, I believe. So let's say, remember, we had defined an age variable previously as 50. So a person with age 50 should be allowed to vote, but someone who is less than 18 years of age should not. So how do we model that within our code? We can use an if statement. So we can say if age, and to compare the age to 18, we can use the less than sign. So if age is less than 18, colon, enter. You can see Colab has indented this for us because it knows that we are about to type something in this if statement here. So if age is 18, you can print, or if age is less than 18, you can print, you are not eligible to vote. And if we run that, we see nothing was printed because age is not less than 18 because it is 50. Now, to attend to the opposite case for when the if statement fails, as it has failed right now, we can use else here. So else can only be used after you've used if. So you cannot, for example, just omit all of this and expect else to work. You can see it's flagging it as wrong. So there has to be an if statement before you can use an else statement. So else we can print happy voting. Oh, sorry, happy voting, like that. And you see happy voting was printed out because Python first checked if age is less than 18, you're supposed to do this. But age is not less than 18. Henceforth, it went with the else route and printed happy voting. So I think that makes sense. Let me check back in with the window for questions. Okay. There are no questions for now. Okay, moving on. So of course, we can do much more than just check if something is less than something else. We can also check for direct comparison. So for instance, okay, yes, this brings me to another data type within Python known as a Boolean. Now, Booleans spelled like this. Booleans named after, I believe he was a mathematician named Edward Boole. Boolean values are used to represent values that are either true or false. So in Python, to represent a Boolean value, let's say is raining. It's not raining over here, so I can call that false. So this is a Boolean value, and it's meant to represent whether or not it is raining at the moment. Of course, the opposite of that would be true. And we define these with capital letters at their beginnings. So let's change that back to be false for now. So is raining is equal to false. Now we can do something with, or rather, we can perform comparisons with Boolean values as well as integers. So we can do something like, okay, let's add temperature. Let's say, or humidity rather. Let's say the humidity is 400, right? So if we wanted to create a weather app, for instance, that is supposed to check whether or not it's raining and check the humidity and all of that, to make a forecast, we could do something like if is raining and humidity is greater than 400, we can print it is raining and humid. Let's change this to greater or equal to 400. Now if is raining and humidity is less than 400. It's less than 400, we can print it is raining, but not, sorry about that. It is raining, but not humid. Yeah. So if we, of course, nothing gets printed out because over here is raining and it is set to false. But what we have here is a joint condition that requires that for this to be printed out, it has to be, or rather, the variable is raining has to be true, and the humidity has to be either greater or equal to 400. So I guess you guys can actually see how we can model more complex conditions and logic using just these basic building blocks. So we've just introduced and in here. So when you have and between logical statements, it means both of those statements must evaluate to true before the entire statement can be true. And remember, an if statement will only run if the entire statement is true. Coming down to this other statement, the other route for the if statement here, it says elif, and this is a shorthand for else if. So if it is raining and humidity is greater or equal to 400, else if it's less than 400. Case here, we check, is this raining? This is false. So automatically, because we have an and here, the entire condition is also false. Does that make sense? Yeah, I believe it does. So to actually get something to print out here, we need to satisfy both conditions. So else, or rather, raining. Okay, since it's raining, it's false, right? And we've checked whether it is raining. Let's have another condition that checks the inverse of that. So of course, when you invert false, you end up with true, right? So the inverse of this variable is given by using an exclamation mark before the value. Oh, sorry, that's the wrong language. We do that rather using not. So not is raining, and humidity is greater or equal to 400. Now, if the humidity is high, but it is not raining, we can assume that it's going to rain soon. So we can print it will rain soon. And if we run that, you can see we get it will rain soon. Now, what this is telling us is we have a condition here that checks if it is not raining at the moment and the humidity is over or equal to 400, then we print it will rain soon. Yes. So let's move on to dictionaries. Now, dictionaries are a data type that allow us to map specific keys to values within the dictionary. So as the name implies, with your regular dictionaries for the English language, you have a word and you have the definition for that word. So the word in the dictionary acts like a key, and the value for that key is the definition for that word. So to demonstrate that, let's make a literal dictionary of words, right? So we can have words is equal to, and to define a dictionary, we use curly braces. So remember, it is square braces for lists, parentheses for tuple, and curly braces for dictionaries. So, that's an empty dictionary. So to define elements within a dictionary, we start with the key for that dictionary. So let's define the word orange. So this is the key, orange, as a string. And then to define the value, we use colon, and then we type the value itself. So we can define the word orange as a color or a citrus fruit, like that. We can define another word as well. What other word can we define here? Let's have the word dog. And for the definition, we can have canis familiaris. So that is our dictionary of words. So we have two key value pairs within this dictionary here. The first key is orange, and the value for that key of orange is this string here. The next key is dog, and the value for that key is this string here, and they are separated with a comma. So let's say we want to get the definition for this word orange. To do that, we simply type the name of the dictionary, and then similar to how we get the values at an index for lists, we also use square braces to get the values for dictionaries. Except in this case, where with a list you would use the index, which would be a number. In this case, you can just use the key directly. So orange. And when we run that, you can see we get the definition for orange. If we change this to dog, you can see we get canis familiaris, which is what we put in as the value for dog within this dictionary. So let's say we want to get a word that is not within our dictionary. For example, plan. If we run this, we can see we get a key error. And it just says key error found. So that means there is no key. And remember, the keys in this dictionary are orange and dog. So there is no key within this particular dictionary by that name of fan. Now, of course, keys, as you can see, can be strings. Keys can also be integers. So we can have a key of 0 and we can give it a value of the number 0 like this and run this and try to access 0. So you can see this looks as if we are supposed to access the first item, but no, that is how you access the first item of a list. This, on the other hand, is a dictionary. So using this is telling that dictionary that you want whatever value has been assigned to a key of 0, not indexes. Indices work only with lists and tuples. So that is how you access items within a dictionary. So to add items to a dictionary, the way we do that is we type in the name of the dictionary, we put the name of the key, let's say chicken, like that, and we can perform an assignment to it like you would with any regular variable. So we are assigning a new value to this dictionary with this key. So let's assign a new value there. Let's call it a poultry, a poultry bird, like that. And if we print out, the value for the key chicken, you can see we get the value we just added to that dictionary. If we print out the whole dictionary, you can see all of the items currently within it. So at this point, let's take a short break and get any questions. Do we have any questions so far? No questions? Okay, okay. If oh, it's getting dark. Sorry, 1 second. I will have to turn on the lights around here. Just give me a minute, please. Yeah. Yes. So let's get back to it. So we've gone through lists, tuples, if statements, as well as strings, integers, floating point numbers. Let's go on to taking user input. So far, we've only been assigning variables within the code directly. But let's say we wanted to actually get feedback from whoever is running our code at that moment. One way we could do that is by using the input built-in method. So the same way print is a built-in method that prints things out to a string or to the screen rather. In the same way, we also have the input method here. So what the input method does is it allows us to type in a prompt. So for example, let's say we are asking the user for their name. So we want to assign the user's input to the variable of name, right? So we can have input, please enter your name, like that. Now, when we run this, you can see Colab also gives us an entry box because this is running in a browser. But if this were running in your terminal, it would simply be a single line that you can type in your value after the prompt. So it says, please enter your name. You can see it's still spinning. So it's still awaiting my input here. So when I type in my name here, it runs. And if I print out that value of name again for us to see, you can see it has set that variable back to my name. Remember, we called it George. Yeah, we called it George somewhere up here. But we have successfully rewritten that variable back to my name. So that is how you take user input within a Python script. So we are past the 1 hour mark right now, but okay, let's take a few more basic concepts before wrapping up. So the next concept we're going to look at is another type of loop. So previously, I made mention of a for loop, right? Now, the main purpose of a for loop is to go through each item inside of that loop and to do something with the item, right? But let's say we wanted a loop that was able to run based on just a condition rather than being based on the items within a list. The answer to that need is a while loop. So to define a while loop, we use the keyword while. So we can say while age, okay, no, that doesn't make so much sense. We can say, okay, let's say we wanted to have a countdown, right? We can say, while, or rather, we can define a number first. So we can say our starting value, so start is equal to 10, right? So we can say while start is less, rather, is greater than 0, we want to do a couple of things. First, we want to print the value of start. So, like that. And next, we want to reduce the value of start by 1. Now, if you recall, there was a shorthand like this for lists, for adding things to that list, right? We can use this shorthand as well on integers and floating point values. And Python is intelligent enough to know what you mean. So we can do minus and equals. So this is going to subtract whatever value we put here. So in this case, we'll use 1. So this is just going to subtract 1 and assign the new value to this variable start. And remember, we had already defined start to equal 10. So what this while loop is going to do is, while the value of start is greater than 0, it is going to run this repeatedly. So let's run this and see. And as you can see, we have our countdown. So it starts out with the initial value. So while start is greater than 0, which it is right now, it is 10. It prints out 10 and it subtracts 1. Then while start is 0 again, at the moment it is 9. So it prints out 9 and subtracts it by 1. So prints out 8 the next time, and 7, and then 6, 5, 4, 3, 2, 1. So there you go. That is a while loop. Now, while loops are very powerful within Python, as they allow us to create code that can run essentially indefinitely. And for that reason, they are used commonly for things like event loops with desktop application programming. So, for example, let's say you wanted to create a simple app that would greet the user, but it would also stand by and wait for the user to enter their name again. So to do that, we can do something like while true. And remember, these keywords, while these keywords like while and if, they evaluate only if their condition equals true. So while true is just going to make an infinite list, or rather an infinite loop, right? So we can say while true, we ask the user what their name is. So name is equal to input. What is your name? Question mark. And we can print out what the name is like this. And if we run this, you can see it says, what is your name? I can type in Divine, enter. It still asks again, what is your name? I can type something else again. It still repeats over and over and over again. Now, because we have no condition that tells this guy when to stop looping, this loop will essentially continue forever until we manually terminate the program, right? So let's do that right now. We've terminated that program. So usually you would want to control the conditions within which your loop terminates, rather than needing the user to manually terminate it, which results in errors, as you can see here. Instead, let's perform a simple check. So if the name is equal to, yes, this is how you do direct equals comparison. So if the name is equal to Divine, we want to break out of the loop. So to break out of the loop, we use the break keyword, just like that. So we also just print the name like that. So if we run this again, you can see it's asked, what is your name? Now, if I give it any name other than Divine, let's say Timothy, you can see it's the name Timothy is not equal to this name Divine. So it does not break out of the loop, hence it runs again. But if we want to break out of this loop with this condition, all I have to do is type that, and you can see it says terminated. We have successfully broken out of the loop. So those are while loops. Again, a very powerful feature. Now let's check out the final feature that we would look at for today. Functions. Now, a function in Python is essentially a reusable block of Python code that you can invoke at any point within your application. So if you had an operation that you wanted to run multiple times and you didn't want to have to type it out multiple times, like let's say I wanted to print my name a couple of times, of course I could use a for loop. So I could say for I in the range of 10. So this means we're doing something 10 times. So for I in the range of 10, print name. We could do this, of course. But let's assume this print statement here was actually a procedure that takes about 50 lines to complete. Of course, we wouldn't want to reuse or rather, we wouldn't want to have to copy paste those 50 lines in every single part where we need to do so within our code. So instead, we can use a function for that. And what a function would allow us to do is we can define a block of code that we can use repeatedly elsewhere. So to define a function, we use the def keyword, stands for define. So if we define this function here, let's call it print name, colon, and enter. Now, these parentheses here are part of what denotes it as a function. And I'll get to the importance of these parentheses and what you can put inside of the parentheses shortly. Okay, so inside of our function, we can simply print out the name, and we can run that. Yeah. So if you notice, there is no output here. That is because we are simply telling Python that we have a function now called print name, and until we actually tell that function to run, all Python has to do is just record what the function is doing. So it does not actually invoke the function when we define it. So to use the function, to invoke it, you actually have to do that separately. So going back to that example of printing my name multiple times, we can do for I in range 10, instead of having our theoretical 50-line block where we would do print name and plus 49 other lines. Instead of doing all that, we can simply use our function print name. Yes, I can hear someone. Any question? Oh, wow, we actually have someone named Timothy in here. Yeah, Donald Timothy, do you have a question? Okay, I assume his mic is just turned on by mistake, so I will go on. So remember, the assumption here is we actually had some code that spanned 50 lines. So let's say we had something like this printed multiple times, right? They wouldn't want to have to type out all of these lines every single time we wanted to do this action. So by using a function, let me do this so that it becomes clearer. So by using this function like this, right, you can see this procedure of printing the name and a digit 10 times. This procedure has been shortened to just this one line here. So these 3 lines have now been represented by calling this function here. So when you call a function, it means you are typing out the name of the function as defined up here, and you are using these 2 parentheses after. So when Python hits this, it checks for the function you've defined previously, and it executes everything underneath. So you can see the result here is divine 1, divine 2, divine 3, and okay, let's remove the for loop. That might get a bit confusing. Yeah. So you can see 3 statements have been condensed into one by using a function. So that is one use of functions. You can use them to improve your code reuse. So you don't have to copy paste large blocks of code in multiple places just to perform those functions. Instead, you can abstract it away and place it within a single function and call that function whenever you need all of those procedures to run. Now, coming back to these parentheses here, right? These parentheses allow you to essentially define what are called parameters, right? Now, another way to view a function is a task to give to the computer to execute. So let's say we wanted the computer to be able to greet someone. So let's say we have a function called greet. Now, of course, to greet someone, you probably need to know the person's name, right? Now, we can have a parameter inside of this function called name. And we can then use that parameter inside of the function body. And remember, the body of a function refers to every line within that function's block. So to actually make the greeting here, you can just print out hello and a comma and name. And by the way, this is going to print these two items on the same line. So let's execute that. And when we change this back to greet, if we try to run this, we will get an error. And you can see the error it tells us is the function greet is missing a required positional argument called name. Now, what that means is we did not supply any arguments to our function. But now you might be wondering, what is an argument? The only thing I made mention of was parameters. Now, arguments and parameters can be used interchangeably, but technically they mean different things. Strictly speaking, a parameter is the name of the variable that you use when defining the function. So in this case, the parameter here is this name that we put in here. Right? This is the parameter. If we went ahead and supplied this function call with an actual value, for example, Timothy, and we run that again, you can see it says, hello, Timothy. And yes, print adds a space in between elements, so we can remove that extra space. We run this again, yes, hello, Timothy. So this value here is the argument. This value is the parameter. So the argument is the input, the parameter is the variable. Does that make sense? Well, there's no feedback, so I assume it makes sense. So those are parameters and arguments within functions. Now, let's do something. Yeah, let's get that error back. Let's bring that error back. It said greet is missing one required positional argument, right? And it is required because we did not give this function a default value to use, right? Instead, we simply said the function should expect to always be given a value for name. So one way to make this error go away, if it is your intention to not require a value, one way to do that is you can simply assign a value right here to right there. And if we run this again, it takes the default value and uses requiring that a value is always given. That is one way. If that is, let's bring the error back. Yes. So that I want to draw a positional argument. Of course, we now know what arguments are. Yeah. What's that we give in here? So again, this would be the argument. But why argument? We understand it's missing because at the time when this was run, this was empty. So we understand why this is missing. We understand that it's just one of them that is missing because there's just one here. We understand that it is required because, again, we did not have a default value like that. We understand what an argument is. We understand that the parameter is called name. What does this positional here mean? Now, positional arguments are essentially Python parameters values to without actually referencing the name of. What I mean by that is typing this like this, right? This greets Timothy. So do this. Name equals Timothy, like that, within the function call. We can do this, and it works, right? But by doing this, this is now known as a keyword argument, right? Positional argument. This by itself is a positional argument, but by bringing back the name of the parameter, it becomes a keyword argument. So that is what the positional in that error meant. Let me punch back the error so we can see that clearer. Yes, so that is what the positional is referring to. If we went ahead and added another parameter in here, and we run this, it should tell us we're missing two. Oh, yes, we haven't to run this. It should tell us we are missing two required positional arguments, name and age. If we went ahead and now we could use keyword arguments in cases where we want to skip giving a value to a parameter that comes before the one you're interested in. Okay, to rephrase that, we have this function with two parameters, name and age, right? Let's assume we wanted to give default values to these guys. We wanted to give the name as Timothy. Oh, sorry. We wanted to give the name as Timothy, and we wanted to give 23. That should not be a string. And let's update this. So it now says, hello, name. You are age years old. Let's run this. Now, this function, I'm not sure why this keeps popping up. This function by itself now has default values for each one of these parameters, so it shouldn't give us an error anymore. It just uses the defaults, which says, hello, Timothy, you are 23 years old. I wanted to actually change for age, right? Remember, what we've been doing so far to give a value to name was to just type in a value, right? Let's change this to divine, for instance. And of course, this changes the name to say, hello, divine, you're 23 years old. But our objective here is to change age, not name. So how do we do that? The answer is keyword parameter directly and assign a new age to it of 70. And like that, you can see it says, hello, Timothy, you are 70 years old. I assume that makes sense, right? Okay. Now, that is the use of keyword. Of course, if the intention was to change both of them, we could also do the line like that, and we could assign an age just like that. So these two are positional arguments right now. If we do this, right now, age is a keyword argument, and the name right now is a positional argument. And I guess you guys can now see why it's called positional, because Python simply assigns the value based on what position it is in a list of all the arguments. So, for example, we can see this is the second item that is being supplied to this function. So based on that, Python can say, okay, this is in position 2. Therefore, it has to be the value for the parameter in position 2. That is why this argument. Yeah. So with that, we have come to the end of this session. I would like to take questions. Do we have any questions?
Yeah, hello Divine. Can you quickly or briefly just talk about libraries in Python?
Oh, okay. Okay. So one of the great things about Python is the community, right? So with Python, anyone is free to go ahead and create code and share that code with others to use within their own code bases. Sorry, 1 second. That was an error. Let me clear that. So when someone creates their own like piece of code that is intended to be shared with the rest of the community, that code is referred to as a module. Now, technically speaking, a Python module is simply just a Python file, right? But the beauty of modules is that we can install those modules as packages into our environment, and we can then make use of that person's code directly. So we don't have to build everything by ourselves. Instead, we can simply find a module that does what we need on the internet. And let me drop this link, pypy.org. That link is one to the Python package index. So that is a website where you can browse packages that other people from around the world have put up for people to use and install. Now, to make use of a module or a package within Python, the way to do that is by using the import statement. Of course, this is after installation. So to import something, by the way, Python comes with a couple of built-in modules when you first install it. So those things that it comes with by default are known collectively as the standard library. And to make use of, let's make use of okay, let's make use of the datetime module, yes. So we can use the import keyword. So we can import datetime like that. And I'm choosing to use a built-in module instead of one from the internet because this is Google Colab and I'm not sure about their policies on installing external modules. Though I do believe it should be possible. We'll get to that. So to use this datetime module that we have just imported, right? If we just type out datetime and dot, you can see we have a bunch of stuff accessible in here. And what you would likely be using the most within the datetime module is going to be the datetime object itself. So the datetime object is used to represent dates and times together. So it represents an instant of time. So to demonstrate, we can type out datetime dot, that is the datetime module, and then we want to access datetime itself. So, or rather, okay, this is the datetime package. Yes, this is the datetime class, and then we can get a method from that. When we run this, you can see we get 2026, 3, 30, 18, 36, 18, 225, 795. What this means is we now have an object, a datetime object that represents the year 2026, the third month, the 30th day, the 18th hour in 24-hour time, the 36th minute, 18th second, and this fraction of a second, like that. So just like that, we have got access to the ability to handle representations of time without having to implement that by ourselves. So that's going back to how I started. That is the beauty of modules. You can simply reuse code without having to implement it by yourself. And this is even more important in very high stakes environments. For example, if you are building a backend system that requires authentication, typically you are not supposed to implement authentication libraries by yourself, especially the low-level security things. You're not meant to implement those yourselves. Of course, the algorithms behind those might be open to everyone to view, but implementing it yourself means that you are taking on the risk of your implementation not handling specific things that a different module has already solved. So unless you're willing to cater to all of those edge cases and if needed, get a security audit, in most cases, that is not worth it. So it is best to just reuse a different module to do that. Of course, the aim of this program is using machine learning libraries. So let's see. Can we install a package that would be useful for that? Yeah. Let's try pip. Okay, pip is available to us. So pip is a command line tool that we can use to install modules from that website that I talked about. That is pypy.com. So to install a package with pip, we simply do pip install, and we can do numpy. Oh, it's already installed. Okay, that's good. Requirements already satisfied. So we can actually just come into our code. Oh, sorry. Let's cancel that. We can actually come into our code and simply import numpy. And just like that, we would have access to all of the goodies that numpy provides to us. So you can see we have advanced mathematical functions here. We also have things that can be used for, I believe, vector math. It's also in here. So very interesting stuff that we will definitely be using in the course of this program. So I'm not sure why that keeps happening. Another way that you can actually import things from libraries is to use this method instead. We can do from and then the name of the package, then import, and then we can import whatever we want from that package. So going back to the datetime module, we can say from datetime import datetime, like that. And we can just go ahead. Let's run that. You can go ahead and just do datetime.now. So if you notice, up here, we did datetime.now, but in this case, we have just datetime.now, just like that. So it works that way now because we are importing this particular datetime directly. So this datetime here, this is the package itself. So we are bypassing the import for the package. So we are saying from this package, just fetch me this object specifically. So from datetime, import datetime. And thus we can use this directly. Yeah. And of course, if you run that, you see we get a similar result as last time. So yeah, that has been an introduction to Python development. Although we did not cover everything, I will make no illusions about that. And thus I advise that you check out the cheat sheet. It is the same one which I am referencing during this, which I was referencing during this talk. And there is the link in chat right now if you want to check it out. So any other questions before we round up? Okay. Okay.
Okay, so I guess there are no questions. So something for the participants. Where do you think they should go from what you've taught today now? Like, what do you advise that the next step should be from here now?
Okay, so the next thing I advise, of course, besides the cheat sheet, is since the aim of this program is machine learning, I would advise they get very familiar with how to use Colab. I would advise they understand what a notebook is, right? This IPyNB extension, it stands for Iron Python Notebook, and it's the file format for Python notebooks. So I would advise they look into what that is. They check out what Colab can actually do, because we've only used Colab on a basic level. It can be used for so much more. I advise they also look more into using pip. And finally, documentation. So 1 second, let me get the link to Python's documentation. So a good thing about Python, as well as most of the modules and packages and libraries that you'll be using in Python, is more often than not, they have very good documentation that you can refer to at your own time. And yes, that is the link to Python's documentation. So you can refer to that if you get stuck. You can search for different concepts within the documentation. And if that isn't enough, then I would advise you look towards other sources online. So like videos and tutorials and all of that. Though I would recommend do not start out by following a tutorial word for word just to complete the tutorial. Instead, you should give yourself a goal and make reference to tutorials only when you do not understand the specific concept that that tutorial covers. And going from there, I think you would find Python very interesting. I've personally been using it since 2018, and it still remains my language of choice for most things.
All right. Thank you very much for that, Divine. So with that, we have come to the end of this session. So if you enjoyed the session, let your reactions come in. Also, connect with Divine on LinkedIn. So tomorrow we will be doing something else that builds on this. We'll likely be using Collab again, Python on Collab. The recording will be shared after. So thank you very much for joining in. Thank you very much, Divine, for showing up. Really
Thank you
appreciate
for
it.
the opportunity. Thank you.
So, guys, there's a feedback form. Please share your thoughts in the feedback form. It will be shared to the community again. Just give your thoughts, whether good or you think it's bad. Just share it there. So we'll know how to improve rapidly. In light of this, we've come to the end of today's session. Don't forget, tomorrow is going to be on data manipulation. We have another instructor there. So thank you all for joining in, and we'll see you tomorrow.